Hi, my name is Megan, and I am a member of the eTREC robotics team at East Troy High School. In this video, I am going to walk you through my team's journey during the 2013-2014 First Tech Challenge season, which was our first as a team. To begin, I would like to introduce you to my team. As I said before, my name is Megan. I'm a freshman at East Troy, and this is my second year on a robotics team. What I love about robotics is going through the design process, which I will introduce to you in a minute. Other than robotics, my favorite pastimes are horseback riding and reading. Nick likes to work with his hands, and has especially enjoyed the opportunities that robotics has given him to work with the tools in the metal shop. He enjoys playing the drums and guitar and snowboarding. Thomas enjoys playing video games and baseball. He participates in concert band and jazz band at school. Casey enjoys math and thought that robotics would be a good fit for her because of it. At school, she sings in the choir. So, how do you build a robot? Well, when we build our robots, we use something called the design process. It is a series of steps that help you plan out and build your robot in an organized manner. The first step is to recognize your problem and lay out the criteria and constraints. Next, you want to brainstorm some possible ways to do whatever your robot needs to do. After that, you choose the best of your ideas that you came up with and build something that shows the basic principles of your idea. It doesn't have to be anything fancy, just something to show your ideas. When you have built prototypes of your best ideas and tested them, you do a proof of concept on the best idea. A proof of concept, again, isn't super fancy and it doesn't have to look finished, but it does have to show that your idea and design are going to work when you build your final product. Now that you have an idea that works and you have your design pretty much finalized, you want to do some final drawings and maybe make any changes that you need to your proof of concept design. When you have a physical robot built, you use a similar process to design and test your programming, which is the instructions that your robot will follow when it moves. After this is done, all you have to do is hook up your robot to power and watch it go. To start off our robotics season, we watched the video that FIRST puts out that tells us what our robot needs to be able to do during the competitions this season. FIRST is the organization that governs FTC, the program we participate in. After watching the video that gave us the details of this huge challenge, we wrote down all the criteria and constraints for each segment of the game. The criteria was everything that we could do in that section to score, and the constraints were all of the rules we had to follow, and the limitations on our robot, our programming, and everything else. We then decided what our targets or goals were going to be, in order of what we wanted to accomplish. After that, we looked at all the different ways that we could accomplish those goals. When we had all of our goals outlined, we started brainstorming different ways to accomplish those things. The first thing we looked at was how we were going to get the scoring element, a 2-inch plastic brick, into the baskets that you can score in. We did this by brainstorming different mechanisms that we could use to pick them up. When we came up with each one of these ideas, we listed the pros and cons for them. Pros were the good things, like how the bucket could hold up to 4 bricks, which was the maximum amount that we could have at one time. Cons were things like how the suction cups would need some way of sticking to the bricks, and we didn't have anything that we could use to make them do that. After we got all of our brainstorming done, we moved on to building prototypes of the better ideas. Some of the ideas we prototyped were a bucket, a conveyor belt with little nubs to help the bricks get on it, and a gripper that looked kind of like a pooper scooper. We made notes on all of the ideas and then decided that the bucket had worked the best, but our original design needed some modification. Our proof of concept bucket was a square that held 2 bricks across and 2 bricks deep, instead of just 4 bricks across. This was the final design that we kept and the one that is on our robot. We repeated the same process we used to design and build the bucket on all of the other components on our robot. These included the hook arms that we use to hang our robot on a bar, the elevator mechanism that raises and lowers the sides on our robot so that the hook arms can hook on the bar, the forklift that raises and lowers the bucket that picks up the bricks, the servo attachment that tips the bucket to allow us to dump bricks, and the mechanism that we nicknamed the pigtail that allows us to turn a handle and raise a flag. In 5 short months, 4 people, 3 of whom had little or no experience with building of any kind, went from drawings on a piece of paper to a fully functional, moving robot. One final thought that I would like to leave you with is this. You don't need tons of prior knowledge, experience, or directions to build robots, or anything for that matter. You learn as you are building, and you get so much more out of that than anything you could get out of a how-to manual or instruction book.